Hello everyone. Today I will present our recent work on pose-guided fine-grained sign language video generation. Sign language is essential for the deaf community, but generating high-quality sign language videos remains a challenge. Current methods often suffer from poor temporal consistency, resulting in unnatural transitions between frames and blurred details, especially in hand and facial areas. This can severely affect the understanding and realism of the generated videos. Our motivation is to address these limitations by creating sign language videos that are both temporally consistent and rich in fine-grained details. Our approach is based on a novel framework we call the Pose-Guided Motion Model, PGMM. The key idea behind this model is to decouple coarse motion from fine-grained detail generation. By doing this, we can more effectively control the motion and details in the generated sign language videos. As shown in the architecture diagram, PGMM consists of two main modules: the Coarse Motion Module, CMM, which handles the large-scale motion, and the Pose Fusion Module, PFM, which focuses on generating detailed areas like the hands and face. The Coarse Motion Module uses optical flow warping to transfer large-scale movements without changing appearance details. This module is responsible for preserving the overall structure of the body during motion. Meanwhile, the Pose Fusion Module employs a cross-attention mechanism to fuse pose-based and RGB-based features. This allows for the fine-grained generation of details, such as hand movements and facial expressions, which are critical for conveying accurate sign language. We evaluated our model on several benchmark datasets, including Phoenix, 2014T, LSA64, and CSL Daily, and compared it with state-of-the-art methods like Dynast, MRA, and TPSMM. As shown in the table, our method consistently outperforms others in key metrics. For example, our model achieves better SSIM and LPIPS scores, which measure visual similarity, as well as a lower FVD, TCD score, indicating improved temporal consistency. Here, you can see some qualitative comparisons between our method and others. On the left, we have examples generated by Dynast and TPSMM. Notice the blurred hand shapes and inconsistent facial expressions in these methods. In contrast, our model, shown on the right, produces much sharper hand details and more natural facial expressions. These improvements are crucial for generating realistic sign language videos. To better understand the contribution of each component, we performed an ablation study. Removing the Pose Fusion Module, PFM, resulted in significantly worse performance in detail generation, as seen in the comparison chart. We also visualized intermediate results to highlight how the Coarse Motion Module controls large-scale movements, while the Pose Fusion Module enhances the fine details like hand and facial regions. These visualizations clearly show the complementary roles of these two modules in our model. To summarize, our key contributions are as follows. First, we introduced a novel framework, the Pose-Guided Motion Model, for generating sign language videos with fine details. Second, we developed two key modules, CMM for handling large-scale motion and PFM for detail generation. Our extensive experiments have shown that our model achieves state-of-the-art results across multiple benchmarks, making it a significant step forward in sign language video generation. Thank you very much for your attention.